Time. Now, we all know time as a unit of measurement that we use on a day-to-day basis without even truly realizing it. But when it comes to physics, time is a lot more than just that. Now, when it comes to time, the most important thing that you need to know is that time is relative. It all depends on the perspective. Now, velocity isn't an actual constant value, but rather a relative one. For example, you can have a train moving at a velocity of 20 kilometers per hour, but it would only be moving 20 kilometers per hour relative to an object at rest. But if you had two trains, train A and train A moving at 20 kilometers per hour and train B moving at 10 kilometers per hour, relative to train B, train A is moving at a velocity of 30 kilometers per hour. So in reality, velocity is quite relative. But there is one exception, and that is the speed of light. Now, the speed of light is a physical universal constant, which means no matter the distance or no matter the observer, the speed of light will always remain the same, at a velocity of 299,792,458 meters per second. But the more you think about it, the more you wonder, how is that even possible? How is it possible that the speed of light is able to reach one point to another at the same time and the same speed, no matter the distance between those 2 points? Whether it be 1 meter or 100 kilometers, it'll take the same amount of time for the speed of light to reach those 2 points. Well, the answer to that is time dilation. Now, time dilation is a concept that Albert Einstein came up with, claiming that the faster you move through space, the slower you move through time. Now, the reason this happens is to be able to prevent things to move at the same speed as light. Let's go back to our analogies of the train for just a second. Now, theoretically speaking, let's just say that one of the trains were able to reach a velocity just shy of the speed of light. Now, you would be able to think that if you ran, it would add up that velocity to your speed, which means eventually you'd be able to reach the speed of light and pretty much be the Flash, right? Well, not exactly. Remember when I said earlier that the faster you move through space, the slower you move through time? Well, this is where this would apply. As the train accelerates more and more closer to the speed of light, time would get slower and slower and slower for you. Because everything within the train would get slower, you would perceive time just normal, as if nothing actually is happening. But if an exterior observer looking in the train saw this, they would see that time for you has completely slowed down dramatically. And this is exactly what time dilation is. So no matter how fast you were running on that accelerating train, even if it was 50 kilometers per hour, it wouldn't be able to reach the speed of light. Because again, the faster you move through space, the slower you move through time. So even though you might feel like running fast, in reality, you're running extremely slowly.